Hi, this is Dr. Staley. There is no audio in the main part of the video. I'm just doing a voiceover because that lapel mic I'm wearing in the video, it turns out, yeah, it's not so good. Anyway, this is the synthesis of nickel complex salt using procedure B. I'm adding the 1 gram of nickel sulfate hexahydrate to the beaker right there. There we go. Now, when transferring a solid into a piece of glassware, one of the things to be aware of is static electricity, but when the piece of glassware is big, like a beaker, that's not actually much of a problem. Here, you know, there's salt, there's some DI water. I believe that's 5 milliliters of deionized water. One of the things to consider when thinking about the volume of solvent to add is that we need enough solvent to dissolve everything, to dissolve the reactants, but we need a small enough amount so that we don't have a problem getting the products to precipitate out. So there was just a cut there in the footage. That's because I was stirring it for several minutes, and I didn't, want just several minutes of nothing but stirring a beaker on the footage. So it's dissolved. And now what I'm going to do is I'm going to go and I'm going to get the ethylenediamine. This is 3.5 milliliters of ethylenediamine that I am adding, I believe. There we go. Of course, using the secondary container to pour it into the graduated cylinder. Then adding a bit more to the graduated cylinder, or to the beaker. Now, ethylenediamine evaporates pretty easily and it smells pretty bad, and it is actually pretty dangerous. So it needs to be used in a hood. That being said, I had to do this on a day when the hoods were inoperable. So that hood does not have the ventilation turned on. This is an example of do as I say, not as I do. And come on, come on. It actually starts smelling better once it's all poured into the beaker because it all dissolves in the water at that point. As you can see, as I'm pouring it, it is becoming a solid. The product is forming as the ethylenediamine is being poured in, and we're getting a solid out of it. There we go. Now the reason I'm shaking it here, and there should be another cut in a little bit, the reason I'm shaking it here is because I want to make sure that all of the big chunks of solid in there are broken up so that the solution gets to everything. One of the problems with a solid forming too quickly is that it can trap reagents that are not finished reacting in it. Also, it can trap things that are not reagents in it. So I want to make sure that that none of those happen. There we go. That is 200 proof ethanol in an ice bath. I'm putting that into the graduated cylinder so that I can pour it into the beaker to make sure that all the product is precipitated out. There we go. Pouring the ethanol in. It's important that this ethanol is cold because the colder that the ethanol is, the more that the salt is going to precipitate. Solids tend to be less soluble in liquid at, at lower temperatures, whereas gases tend to be less soluble in liquid at higher temperatures. There we are. Just about done. So this is also the thing where I'm trying to, make sure that all the big chunks are broken up. Could have sworn that I cut out a few minutes of this shaking. I guess I didn't. There we go. Yes, that's the mixture right there. Now, unlike with the salt made using procedure A, this salt is significantly less soluble, which means that I can just take it and do the vacuum filtration right away instead of needing to put it into the ice bath. And as you can very clearly tell, I'm using the webcam that is on my laptop. So because I don't need to let the salt recrystallize anymore, I'm just going directly to the vacuum filtration. Here we've got the Bruckner funnel and the top of the vacuum flask, and there's the vacuum flask connected to the solvent trap. The vacuum flask is the one in the center of the screen. Solvent trap is the one off to the left a little bit. I just got some more solvent. Now, that ethanol is what I'm going to use to wet down the filter paper once the vacuum is on. And it's also what I'm going to use to rinse everything down later. There we go, swirling it, and pouring the mixture onto the filter paper. Now it's important to get this mixture on the center of the filter paper because if it gets to the edge, then there's a pathway that we can lose some solid because it can be potentially sucked around the edge. So here I'm trying to show where it is on the filter paper. Unfortunately, I did not know that the room was too bright for this. And just adding some more ethanol because when you pour out a mixture as thick as this, a lot of it sticks to the sides of the beaker, and I want to get that off the sides and pour it in. Now there's a difference between something that's suspended in a liquid and something that's dissolved in it. When it's dissolved, the individual molecules, or in this case individual ions, are actually physically separated from each other. When something is suspended, it's more like there's chunks of it, and those chunks are separated from other chunks and also are separated from the glass of the beaker. If I was doing this with, for example, an aqueous acid instead of ethanol, then this wouldn't work at all because that would just outright dissolve the solid. And out of ethanol, gotta get some more. There we go. Back with some more. Make sure to hold on to the beaker nice and tight if you have to shake it. Okay, so now that it's all on the filter paper, I need to make sure that I rinse it with the solvent. This makes sure that any uh, drops of solvent that are on or in the solid uh, are drops that are only just pure solvent, so that it can evaporate away. You don't want any unreacted reactants or potentially side products. In this case, I don't think that we have any notable side products, but you don't want any non-reacted reactants, you know, messing up your nice, pure, beautiful products. And there we go. So I've got the whole thing on there. I'm going to leave it on the vacuum for several minutes. Then I'm going to put it into a hood to dry off. And once it is dry, tomorrow I will be measuring the mass and figuring out the yield. Okay, cool. Well, thanks a lot.